Hi, in this video, I'll be solving this problem right here, and it comes from the Philippine Mathematical Olympiad from 2019. The Philippine Mathematical Olympiad is interesting in that for their national round, they include an oral exam component. The contestant or the student comes up and they're given problems and they're supposed to just solve it right there, I guess, on a board in front of judges. For the last few years, I have not seen those oral exam questions, and I assume that the pandemic has something to do with it. But this problem here is not from the oral exam component, it's from the written exam for the national round in 2019. And the solution that I'm giving you here is not the officially published solution. The officially published solution is perfectly good, but to me, I thought it's a little too good. What I'm presenting to you will be the kind of solution that a typical student would come up with as they try around for solving this. All right, find all functions f from R to R such that f of 2x plus f of x plus y, okay, so a double f there, is equal to xfy plus y of x plus f of x plus y for all real numbers x and y. This is what's called a function equation or a functional equation. And the typical way of solving it is to plug in values that you think will simplify the equation. And typically, we'd be plugging in numbers that cause a lot of things to become zero. In this case, it looks like if we use x equals y equals 0, it will simplify a lot of things. So let's try that. F of 2xy, plug it in, we get f of 0. F of x plus y, plug in 0, we get f of 0. Okay, x fy, so x is 0 is gone. Y fx, y0 is gone. F of x plus y, 0 plus 0 makes 0. And we can subtract f of 0 both sides. We end up with this, f of 0 equals 0. What that means is that this part here is a 0 of the f function. And remember, we want to plug in values of x, y that will simplify the equation. And definitely a 0 of a function will simplify it. So definitely we're going to plug in f of 0 into the equation. Where do we plug it in? There's an x and there's a y. Which one do we plug it in as? Well, if you look at the equation, you will see that the x and y are interchangeable. This is an equation where x and y are symmetric. So it doesn't matter. So I'm going to plug in f of 0 as one of them and the other probably 0, just to make it go away. I'm going to plug in y equals to this 0 of the function f, and x is equal to 0 itself. F of 2xy, x equals 0, so the whole thing is just 0. F of x plus y, x is 0, y is f of 0, so the whole thing is, so check this out, f of f. The x plus y cell is equal to f of 0 plus 0. So that's f of 0. So now we have 3 f's in there. Equals x fy, x is 0, so that's just 0. Y fx, y is f of 0. And x is 0, so fx is f of 0. So altogether, we get an f of 0 times another f of 0. Plus f of x plus y. X is 0, y is f of 0, so it's f of 0. It looks like a lot, but it isn't, because remember, all of this is 0. All of this is 0 because of this star equation. So the star equation allows us to simplify all of this. F of 0 plus f of all of this is just 0 is equal to 0 plus. Then f of 0 times itself, so that's squared, and the other is just 0. Oh, look, now I have an equation in just one unknown, and that unknown is f of 0. Imagine that if this is a u, then basically I have 2u is equal to u squared minus 2u equals 0. Then u is equal to 0 or 2. 2 of f of 0 is equal to f of 0 squared, and that means f of 0 is either 0 or 2. I have two possible values for f of 0, so I guess I need to separate them out. Let's do the case of f of 0 equals 0 first. Let's continue solving the function equation the way most of them are solved, and that is just to plug in different values. We already did x equals y equals 0. We already did one of them equals to f of 0, which is a 0 of the function f. So now let's do something that's a lot more normal, and that is one of the xy is 0 and the other isn't. That's a very standard step. Again, because x and y are interchangeable, it doesn't matter. So I'm just gonna plug in the case y equals 0 and x is just x. F of xy, y 0, so the whole thing is just 0, plus f of x plus y. Y 0, so the whole thing is just x. X f y, x f of 0, plus y f x, y 0, so y f x is just 0. F of x plus y 0, so the whole thing is just x. Oh, guess what? We assume that f of 0 is 0, so that's a 0, that's a 0. F of x is equal to fx. This looks important, so let's just name it. It looks important because now whenever I see a double f, I can treat it as just a single f. And guess what? The original equation has a double f on the left and a single f on the right that are the same, x plus y. So since they're the same, they should be cancelable. Ooh, I'm gonna plug this star into the original equation. And because double f and single f are the same, I don't need a double f. And that means these can be subtracted both sides. And now I have a lot more simplified equation to deal with. This equation is a whole lot simpler than the equation that was originally given. I'll continue trying to simplify this by plugging in certain things. Well, and one thing that I will try now is to try to simplify this, because all of these are pretty simple. It's a 2xy that's complicated. So I'm going to try to do it so that all of the 2xy is equal to just x. So I want 2xy to be equal to just x, and that means I want y to be equal to 1/2. I'm going to plug in y equals 1/2. And this becomes just f of x. Y is 1/2. Oh yeah, x is just x. And over here, 1/2. Combine like terms. multiply both sides by 2, I get f of x is equal to all of this times 2. Now, this is a constant. F of 1/2, therefore, is some kind of constant. And I multiply that by 2, the whole thing is just some constant. So I'll just call it A. Then it says that my function f of x is equal to some constant a times x. I'm practically home free now. All I need to do is find a. So I'm going to take this form and I go back up. I look for something I can plug it into. I can try plugging into this one. F of x is equal to f of x. F of x is ax. F of x is a times ax, which is a squared times x. And since this must be true for all x, I could throw in x equals 1, or I can think of it as canceling x both sides. Either way, I get a squared equals to a, meaning a is equal to 1 or 0. So that means f of x is equal to x, the identity function for all x in R, or f of x is equal to 0, constantly equal to 0 for all x in R. Done. At least for the case f of 0 equals 0. Now let's do the other case, the case that f of 0 is equal to 2. Let's try doing the same steps as the case f0 equals 0, because why not? And if it doesn't work, then let's try something else. But since it worked so well last time, let's do it now. So first, plug in y equals 0, x equals x. F of 2xy, y equals 0, so the whole thing is just 0, plus f of x plus y, y equals 0, so the whole inside is just x, and there are two f's on the outside, equals xfy, y equals 0, yfx, y 0, so the whole thing is just 0, plus f of x plus y, y 0, so x plus y is just x, like this. Last time we were able to cancel out f of 0 pretty neatly because it's just equal to 0. Now we can't because it's equal to 2. Oh, well, then we put in 2. This is a 2, that's a 2. 2. Last time we had a very nice relationship that has a double f is exactly equal to a single f. This time, a double f is not identical to a single f, but it has some extra stuff. It's okay. Let's write it. Last time we had a very nice relationship between a double f and a single f, and we plug it into the original equation, and then the double f and the single f cancel each other out. This time we don't have such a nice relation, but we still have a relation between a double f and a single f. That means we will still be able to cancel them out. There's some extra stuff left, 2x minus y, but at least we get rid of the double f. So for example, this means that f of x plus y now let's plug all of this into the original equation. F of 2xy plus f of x plus y, which we can substitute with all of this stuff, is equal to, and whatever is on the right-hand side. And the f x plus y cancel. It didn't simplify much, but it did simplify us out of the double F. So now we can continue with what we did last time, which is to plug in y equals 1/2 so that the 2xy becomes just x. This first term is just f of x plus all of this stuff, plus 2x plus 2y. 2 times 1/2 is 1. We can still do what we did last time, and that is to solve for f of x by combining like terms. These together is -1, and then I add 1 both sides, so it's +1 on the right side. Multiply both sides by 2. And I can factor an x out of here. And I have my fx. It looks like a mess, but just like last time, I noticed that this is a constant, 1/2. So f of 1/2 is a constant. Multiply that by 2 is a constant, and subtract 4. It's a constant. The whole thing is some kind of constant. My fx function is now equal to ax plus 2. Almost done. All I need to do is to find what a is equal to. So I'm going to take this, I'm going to plug into something. Well, let's see what to plug it in as. Right, none of these matter because all of these are the case of, oh, how about this one? What if I go all the way back here? Plug into f of 0 equals 0. This one's going to work because my function f is a linear equation that's off of the origin. So when I do it double, it will preserve the a. F of x is equal to a times fx plus 2, which is a times ax plus 2, which is a squared x plus 2a plus 2. Right, and so f of 0 is equal to 0 plus 2a plus 2, and that is supposed to be equal to 0. That gets me a equals -1. Fx is ax plus 2, therefore f of x is equal to -x plus 2. Right, that's the solution for the case of f of 0 equals 2. So together with the other two solutions I got previously, these are the 3 solutions. All right, hope that's been fun. Any questions? Please put in the comments below. Subscribe for more contents, and thanks for watching. Bye.